So good morning, children. Welcome back to ICAN Physics. Now in this class, we are going to start the sixth lesson, electromagnetic induction, which is very interesting one. So let us see the problems from exercise. Okay, let's enjoy the class. Right. So first one, a coil is connected with the external circuit. Here we are having the magnet. Here, this is the very important one. Why? Because the direction. Okay. Appa, first time engama porom appadina, whenever there is a change in flux, the flux is directly proportional to induced current. Is given by Faraday. Next, the rate of change of flux is directly proportional to induced EMF. That also given by Faraday. Okay. Now, rate of change of flux is directly proportional to induced EMF, which is produced in the opposite direction, was given by Lenz. Okay. Here, this one is the important to solve nearly all the problems. Okay. Now, the magnet is moving towards the coil. According to Lenz, the nearer end is also acting as south pole. The south pole repel each other. Okay. So, I must do some work against the repulsive force, so that the induced EMF is produced in the opposite direction. So, I am moving the magnet in this direction. So, the induced current is produced in this direction. So, the current is flowing from P to Q. Okay. Do you get it now? Do you have any doubts? No doubts. Okay, the second one, the same logic. The south pole is placed nearby the first coil. The first coil is also acting as a south pole. So, south pole repel each other. So, I must do some work against the repulsive force. So, see the arrow mark? Arrow mark is like this. So, the magnet is moving in this direction. So, the induced current is flowing in this direction. So, it will be from P to Q. At the same time, when you are going to the next coil, when it is moving away in this direction, so the magnet is moving in this direction, so that the induced current is flowing in this direction, then it is X, Z, Y. Okay, do you get it now? Do you have any doubts? No doubts. Okay, the third one, the key is just closed and closing the key. So when the key is closed, then the current is flowing in the clockwise direction. The current is flowing in the clockwise direction. Automatically, the induced current is produced in the opposite direction. So it flows in the anti-clockwise direction. That is X, Y, Z. X, Y, Z. Okay? Do you get it now? Do you have any doubts? No doubts. Now go to the next one. Here, the rheostat is being changed. So, when the rheostat is changed, the amount of current is changed. When the current flowing is changed, then there is a change in flux. The change in flux produces induced current and induced EMF. Just see the battery. It's positive, negative. So, the current is flowing in the anti-clockwise direction. Just see that. The current is flowing in the anti-clockwise direction. So, the induced current is flowing in the clockwise direction. So, it will be X, Z, Y. X, Z, Y. Otherwise, some of them are saying Z, Y, X. Z, Y, X. Or otherwise, Y, X, Z. Y, X, Z. So, whatever may be the answer, it will be correct. But only one thing, the current is flowing in the clockwise direction. Okay. Now, the question number E. When the key is just released. When the key is just released. Okay, what happened? The current flows. Just it tries to decreases. So that the current flows from X to Y. X to Y. Okay. And the last one, F. The straight conductor carrying current. Then automatically what is the expression for that? B equal to mu naught I by 2 pi A. And this is the area which has its own magnetic field. But one thing we have to notice, when the current flows through the straight conductor, there is no change in flux. So there is no induced EMF. So induced EMF is not produced in this straight conductor. Do you get it now? Do you have any doubts? No doubts.